For decades, scientists searched the universe for a planet like Earth. Rocky, mild temperatures, liquid water. But the planet that's now making them uneasy doesn't look like Earth at all. It doesn't have continents. It may not even have land. And if something is living there, it's not something we would recognize. The planet is called K2-18b. And when scientists finished analyzing the data from the James Webb Space Telescope, the reaction wasn't celebration. It was hesitation. Not denial, not excitement, silence. Because what Webb detected wasn't just interesting. It was chemically strange and possibly alive. K2-18b sits about 120 light-years from Earth, orbiting a small red dwarf star in the constellation Leo. On paper, it didn't stand out much at first. Astronomers catalog planets like it all the time. It's bigger than Earth, more massive, wrapped in a thick atmosphere. For years, planets like this were dismissed. Too large, too gassy, too alien. Then the data started coming in. The James Webb Space Telescope wasn't designed to photograph continents or oceans directly. What it does instead is something far more subtle. It looks at starlight passing through a planet's atmosphere as the planet crosses in front of its star. That light carries fingerprints, chemical signatures. Every molecule leaves a trace. And when scientists examined K2-18b's atmosphere, they found something they didn't expect to see together. Methane, carbon dioxide. Those two gases shouldn't coexist in large amounts for long periods. They react, they cancel each other out, unless something keeps replenishing them. On Earth, that something is life. At first, researchers assumed there had to be another explanation. Volcanoes, chemical reactions, exotic physics we hadn't fully modeled yet. Then came the third signal. A possible trace of dimethyl sulfide, known as DMS. On Earth, DMS is produced almost entirely by living organisms, mostly microscopic life in oceans, plankton, microbes. There are no confirmed non-biological processes that generate it in large quantities. That doesn't mean life has been found. But it does mean scientists suddenly found themselves standing on unfamiliar ground. This is where the tone of the conversation changed. Because instead of asking, could this planet support life? The question became, what if it already does? K2-18b isn't like Earth. It's what scientists now call a Hycean world. A planet covered almost entirely by a global ocean, with no continents, no shorelines, and a thick hydrogen-rich atmosphere pressing down from above. The gravity is stronger than Earth's. The air would be unbreathable. The pressure at the ocean floor could crush anything we know. If life exists there, it wouldn't walk. It wouldn't build cities. It wouldn't send radio signals. It would exist quietly, in darkness, in chemistry, and that's what makes it unsettling. For most of modern history, the search for life was framed around intelligence, signals, technology, something that could wave back. But K2-18b suggests something far more disturbing. That life might not be rare. It might be common. And it might not care whether we ever notice it. Scientists have been burned before. In the 1970s, the Viking landers on Mars detected chemical reactions that looked biological. Headlines followed. Then, disappointment. In the 1990s, a meteorite from Mars appeared to contain fossilized microbes. The claim collapsed under scrutiny. Every false alarm hardened the rules. Extraordinary claims require extraordinary evidence. So when Webb's data arrived, no one rushed to microphones. They slowed down. They double-checked. They ran simulations designed to disprove life, not confirm it. And that's where things became uncomfortable. The chemical models struggled. Yes, there were theoretical, non-biological explanations, but none were clean, none were satisfying. Every explanation required assumptions stacked on top of assumptions. And when scientists start piling assumptions, they grow cautious. What scares researchers isn't the idea of aliens visiting Earth. It's the math. If life exists on K2-18b, a planet completely unlike Earth, then life may arise easily wherever conditions allow chemistry to run long enough. Which means Earth might not be special at all. It might be typical. Think about what that implies. If microbial life appears naturally on ocean worlds, then the galaxy could be filled with living planets that never evolve intelligence, never build civilizations, never leave artifacts. Entire ecosystems could rise and fall without ever being noticed. Life, abundant but silent. This changes the meaning of the search. For decades, astronomers listened for radio signals, scanning the sky for artificial transmissions. But what if intelligence is rare and life is not? What if most living worlds never speak? That idea unsettles even seasoned researchers, because it reframes humanity's position in the universe. Not as unique, not as chosen, just one outcome among many. There's another uncomfortable detail. K2-18b orbits a red dwarf star. These stars are smaller and cooler than the Sun, but they are volatile. They flare. They erupt. They bombard nearby planets with radiation. For years, scientists believed red dwarfs were hostile to life, and yet many potentially habitable planets orbit them. If life can survive there too, then life is more resilient than we imagined. Which raises another question. If life is so hard to kill, why haven't we seen evidence of intelligent civilizations? This is where K2-18b quietly brushes against the Fermi paradox. If the universe is full of life, where is everyone? Maybe intelligence is rare. Maybe civilizations collapse quickly. Or maybe life usually stays microbial, never developing technology at all. K2-18b doesn't answer that question, but it makes it harder to ignore. NASA and the European Space Agency have been careful with their language. No press conferences declaring life. No bold announcements, just carefully worded papers. Phrases like consistent with, statistically significant, requires further observation. To the public, it sounds underwhelming. To scientists, it's restraint. More observations are already planned. Webb will look again and again, checking whether the signals persist. One detection is curiosity. Repeated detections become evidence. But even then, confirmation could take decades, because admitting life exists elsewhere isn't just a scientific milestone, it's a philosophical one. If life exists on K2-18b, then biology isn't fragile, it's opportunistic, which means the universe may not be quiet because it's empty. It may be quiet because most life has nothing to say. There's a final detail that rarely makes headlines. If K2-18b hosts life, it's likely older than humanity. The star it orbits formed billions of years before the Sun. Life there could have been evolving, while Earth was still molten. Entire biological histories may have played out before humans ever existed. And we would never know. That realization changes the tone of discovery. It's not triumphant, it's humbling. Scientists didn't find aliens on K2-18b. They found something more unsettling. They found evidence that life may not be rare, that it may arise quietly, persist stubbornly, and exist entirely without us. The question is no longer whether we are alone. The question is whether the universe ever needed us at all. To understand why K218b unsettled scientists, you have to understand how rare this moment actually is. Astronomy doesn't move fast. Discoveries aren't made overnight. They are built slowly, painfully, over decades of incremental progress. Most exoplanets are discovered as numbers on a spreadsheet. Orbital periods, mass estimates, temperature ranges. They're not places. They're data points. K2-18b became something else. When astronomers first detected it in 2015, it barely made headlines. It was catalogued, labeled, and quietly archived. Another planet, another orbit. But unlike Earth, K2-18b orbits extremely close to its star. Not because it's hot, but because red dwarf stars are dim. To receive enough warmth for liquid water, planets must huddle close. That closeness comes at a cost. Red dwarfs are unstable. They flare violently. They spit radiation like cosmic shrapnel. For years, scientists assumed planets like K2-18b were sterilized early in their history. Dead worlds. Then something unexpected happened. Follow-up observations suggested water vapor in the atmosphere. That alone was unusual. Water vapor meant not just water, but an active water cycle. Evaporation, condensation, movement. Suddenly, K2-18b was no longer just a planet. It was a system. This is when the debate quietly started behind closed doors. Astrophysicists, chemists, planetary modelers, not asking if life existed, asking how it could exist, and why it shouldn't. Because science advances not by belief, but by resistance. The models didn't agree. Some simulations showed runaway greenhouse effects. Others showed crushing atmospheric pressure. Others suggested oceans so deep that chemistry would stall. But none could completely eliminate the biosignature explanation. And that's where unease crept in. The James Webb Space Telescope changed everything because it removed ambiguity. Previous telescopes hinted. Webb measured. It didn't guess at molecules, it identified them. And when independent teams ran the data, they reached the same conclusion. The signal was real. Methane shouldn't be there in that quantity. Carbon dioxide shouldn't coexist with it stably. And if dimethyl sulfide is confirmed, it forces a question no one is ready to answer. Because DMS isn't just associated with life. It's produced by metabolism. This raises a quiet but devastating possibility. Life may not announce itself with technology. It may announce itself with waste. On Earth, microbes transformed the atmosphere long before intelligence appeared. Oxygen itself was once a biological accident. For billions of years, life reshaped the planet without intention. K2-18b may be doing the same thing now. And if that's true, then we may already be late to the discovery. Life may have existed there for eons. Lived, changed, adapted, all without witnesses. This is why some scientists describe the discovery as sobering. Not thrilling, not celebratory, sobering. Because it reframes our role. Human history is filled with moments where we believed we were central. The Earth was once the center of the universe. Then the Sun replaced it. Then the galaxy. Then billions of galaxies. Each step reduced us. K2-18b threatens to do the same thing to biology. If life exists there, it means life is not fragile. It is not rare. It is not precious. It is inevitable. and inevitability removes meaning. There is another layer to the fear, one rarely discussed publicly. If microbial life is common, then intelligent life may be rare not because it's unlikely, but because it's unstable. Civilizations may destroy themselves, or stagnate, or choose silence. ETA 2-18b suggests a universe filled with living worlds that never progress beyond chemistry. Alive, but quiet. Occupied, but empty of voices. This challenges decades of SETI assumptions. We've been listening for messages. But what if the universe communicates through atmospheres instead? Through chemistry? Through imbalance? Some researchers now argue we've been asking the wrong question. Not, who is out there? But, how much life has already come and gone? 2-18b also forces scientists to confront a darker scenario. If life is common, then extinction must be common too. Planets flare, stars evolve. Habitability windows close. Life may bloom briefly, then vanish. Civilizations, if they arise at all, may be short-lived sparks in a long cosmic night. This could explain the silence, not emptiness, but impermanence. The more Webb observes, the more it reveals uncomfortable truths. Planets are stranger than expected. Habitability is broader than imagined. Life doesn't require Earth-like conditions, just time. And time is abundant. Future missions will target K2-18b again. They'll look for repeating chemical patterns, seasonal changes, atmospheric disequilibrium. They'll test every alternative explanation until only one remains. But even then, no announcement will say, "We found life." It will say, "This result is consistent with biological activity." Careful words. Measured words. Words that change everything without sounding like it. And that may be the most unsettling part. The discovery of life elsewhere may not arrive as a headline. It may arrive as a footnote, a statistical certainty, a quiet realization that we were never alone and never special. K2-18b doesn't promise contact. It doesn't promise answers. It offers something more difficult: perspective. Because if life exists there, then the universe isn't waiting for us. It never was. We searched the stars for neighbors. Instead, we may have found evidence that life doesn't need company. It simply exists, where it can, as long as it can. And when it's gone, the universe doesn't notice. K2-18b didn't reveal aliens. It revealed humility.